In this example, we're going to look at how we figure out the area when part of it is above the x-axis and part of it is below the x-axis. So you need to look at this booklet, and within that booklet we're doing this page in particular, and within this page we are looking at this example here. There's quite a few notes and so on this page for you as you go through it. But we are just going to focus on doing the example, so you can complete the note as we go through it. So I think one of the most important tips or strategies was to begin this type of problem by just doing a quick sketch of it, so you get an understanding of what it is you're trying to work out. If you can do that, it's a big help. Sometimes you can, sometimes it's a bit complicated. This one, however, should be fairly straightforward because it's just the graph of y equals 2x minus 4, which is just a line, a straight line, something like that. Y equals 2x minus 4. We are interested in evaluating it between the limits of 4, which might be about there, and minus 2. And in particular, we are trying to figure out what that area is between that bit and the bit underneath. We are trying to calculate that area there. And the first complication we need to sort out is finding out what this point is where it changes between being underneath the x-axis to above the x-axis. So we have to figure out that, which of course is the x-intercept. And of course we just set y equal to 0, just like finding a root or whatever. So we are solving the equation 2x minus 4 equals 0. So we get x equals 2. So now we figured out it's 2 at that point there. So now we need to work out the area. We need to do it in two separate parts. We need to work out the top and the bottom separately, because if we don't, our answers will just end up cancelling each other out. So try and communicate what it is you're doing. We are going to work out the area above, first of all. So let's just call that area 1. And then that is just a case of integrating between the limits of 4 and 2, the function 2x minus 4 with respect to x. Fairly straightforward. Add 1 to the power, divide by the new power. And of course simplify as much as you can before you start trying to substitute things in. So it comes down to x squared minus 4x. At this point we need to put in our limits. So we get 4 squared minus 4 times 4. Take away 2 squared minus 4 times 2, which gives us 4 squared is 16. Take away 4 times 4 is 0. 2 squared is 4, minus 8 gives us minus 4. So the area above is nothing minus minus 4, which is 4 squared. Now we're ready to work out the area below. I'm just going to make a little bit of space for me to do that. Maybe not. The area below is a little bit more straightforward because we've already done most of it. We can call that area 2. We've already done the integration, we don't need to do that again, so it's just the same function integrated. So it's x squared minus 4x, but this time we're integrating it between the limits of 2 and minus 2. And it gets even easier than that because this upper limit for the second thing we're integrating was the lower limit in the previous one. So we already evaluated it down here and got an answer of minus 4. So we don't actually need to even bother evaluating that again because we already know that it comes to minus 4. So that only leaves us to substitute in minus 2 and evaluate what that comes to. So minus 2 squared is 4. Minus 4 times minus 2 is plus 8. So we get 12. Which gives an answer of minus 4 minus 12, which is minus 16. Now at this point it's important that you realise an area can't be negative. So you need to ignore the negative sign at that point. It's only working out negative because the fact that it's underneath the x-axis, but physically it can't be negative. So that's it more or less done. The final step, of course, is just to work out the total there. Giving us an answer of 20 units squared. So you should have a go at some of the questions that that booklet directs you to. Enjoy.